Okay, now I started the recording. So hi everyone. My name is Yota Kawashima. I'm a research assistant at ATL in Japan and Monash University in Australia. Aniko, you go next.
Yeah. Hi, I'm Aniko Kusztor. I'm a PhD student at Monash University.
And Ryoichi.
Hi, I'm Ryoichi Watanabe at Kyoto University, Japan, and I'm a PhD student.
Okay, thank you, everyone. So today we are going to discuss a paper, activity in perceptual classification networks as a basis for human subjective time perception, published in 2019 in Nature Communications. And the authors are Warrick Roseboom, Daphne Ross Pontas, and Kyriakos Nikiforo, and David Bowmick, Mirai Shanahan, and Anil Seth. Okay, I'm sorry if I pronounced the name in the wrong way, but so first I'm going to give you a bit of the summary of this paper. So just briefly, this paper is investigating what is the mechanism of human time perceptions, right? So some people suggested some kind of mechanism called a pacemaker. So the internal clock, that has a time function. But in this paper, what the author says that just some classification neural network system can be used to infer or to estimate the time. So basically the human time perception can be achieved by just non-temporal, like perceptual classification processes. So that's what the author claims. So specifically, the time duration can be inferred based on the accumulation of changes in activations, not the pacemaker. So what it means is that, let's say, we have some neural systems, and the system receives input. And within the system, there will be some activation, or some activation pattern can be observed. And in the next step, when another input will be another input are received by the network, there will be another or different patterns of activation in the neural system. And here, like a big picture idea is that check the differences between the neural activation pattern between these two and see whether it's large enough. If it's large enough, then some mechanism detect or count the difference as significant, and then just accumulate that kind of the significant difference as time goes. And as the accumulation goes, and the difference will be, or the amount of the count will be large, it means that the time passed long, not short. So if let's say we count 10 differences, then we can have some 10-step time. On the other hand, if we count only 3, it means we have only 3 time differences, or the time scale. in this paper, what the author basically did is to first get the subjective experience of time. So show some videos to subject and ask them to rate the duration of videos. And after that, the author input the same videos to the neural system. And then from there, they use some algorithm to estimate the time duration, which I explained before, and then see whether the subjective report and the estimated time duration from the neural network matches or not. And what they found is that when they include some attentional effect or attention as a function in the network, the prediction from the network behave very close to the subjective experience, subjective report. And they conclude that not the time pacemaker, but just checking the difference between neural pattern in the neural network is just sufficient for time perception, or just to estimate the time durations. They also suggest, or this is kind of just preliminary or simple simulation work, so they can extend this mechanism to more human-like neural networks. Specifically, I'm saying that in this paper, they are just focusing on visual information, but if they can include some auditory information or other body sensation, then that can be inferred or predict the time perception more precisely. If I summarize this paper, what the author tried to say is that that kind of seeing the difference in neural pattern is enough, or is the key mechanism for human time perceptions. That's the summary from me. Do you want to add anything on this, Aniko, Ryoichi? Okay, so if not, maybe we can just go straight to the discussion, but Aniko.
Oh, actually, so I'm realizing, I think you mentioned this shortly, but I think it makes sense to emphasize this, that they base, or one of their core idea is to test the biases, or like the estimation biases that people tend to make, and kind of reproduce them with this neural network based model. And so one of the examples they mention is that if you walk, for example, in a busy street, it might feel like less time than as a like less stimulating environment. And so for the videos, they have used or they have categorized these the stimuli into categories of highly variable or high saliency videos that contain highly salient and like complex stimuli, and also more simple, more lower pace changes in less complex stimuli. And yeah, so I think this was also an important aspect that and an important inherent assumption that they make, that based on previous psychological results, or that people actually have biases in their time perception.
Yeah, thank you. Yeah, Aniko. So as Aniko mentions, the authors focusing on some like biases, so the context-dependent time perception, and also attention-dependent time perceptions. And another one is that when subject or when they ask subject to report the duration of videos, the human subject tend to overestimate the shorter videos, but underestimate longer videos. That's the kind of biases tested in this paper, I think. Do you want to add anything, Ryuichi?
Yes, so and in this study, the authors made the model of the feed-forward only model, right? It is not include the feedback or something.
Not. So basically what they did was first train the network and then input the video into the trained network. So there are no like feedback, or I think the reconnecting or changing weight or something like that. Anything else? Okay, if nothing, then maybe we can go to the discussion part. So do you have any like comments or questions? If not, maybe I can first make a comment. So what I feel interesting is that this is, well, I have one comment and one question, and first I will make comment. That is, so this paper kind of implied that no time perception will be achieved if there are no input. Is it correct, or is my understanding correct? So that's a kind of interesting, because I don't know when, but like a few weeks ago we discussed whether the brain can have consciousness if we like cut the brain or remove only brain from body and then somehow like connect to, let's say, I don't know, or put the brain into some liquid so that the brain just can like work well or something. And if we consider that kind of situation, then such a brain will not have time perception. That's one prediction what we can made from this results. So I feel, I don't know, if we only focusing on the difference in the neural pattern, we can probably says that, well, even if we remove brain from body and then put them in some liquid, the state of the brain will just change. So we can probably have some time perceptions. But I think the author kind of says that the context, or I think if I interpret correctly this paper, the author says that the context-dependent classification or perception classification network is important for time perception. So means that without like content, or we cannot perceive any time. That's kind of interesting for me. So do you want to add anything on this?
Yeah, so I was also thinking about this, and I also had some questions about this. And yeah, so you mentioned like any kind of perceptual content, which is in this paper visual content, but then they mentioned that you can add auditory contents and also interoceptive, so bodily signals later on. So in that way, you can imagine there are multiple ways how your brain can collect some kind of information and fluctuations in the information and the saliency of that information, and use that to measure time. And so two things that I wanted to bring up, which are both very similar to your example, Jota. So, for example, sleep. Technically, we don't have external input, but still people actually are rather good. If I'm correct, or I recall it correctly, I think people are fairly good at estimating how much time they spend sleeping. And so, yeah, so in this way, for example, I wonder, and also the other interesting thing is, I think there has been a study on this, that people are actually quite good at estimating how much time they spend in a dream. So when they wake them up and yeah, if they have a dream recall, then actually people are not that bad in saying how long they have been dreaming. And you can kind of look at the brain activity and confirm this. And there seems to be a correspondence between it. So then I wonder, like, is it actually the content that informs the brain, or it's more something else? Because, for example, I'm not sure how could you use informations from dreams in a similar way to assess time. And also, how about dreamless sleep, when you don't have any conscious recollection of any kind of sensory information? I guess you could say that there still might be some bodily signals that technically could be processed. But yeah, so I think that's a quite interesting situation. So do you have any ideas how would this network depend or network state dependent model work in sleep, for example?
So you, in a sense, imply that the interoceptive information will be key, specifically while dreaming. And I think we need to make sure that when we say content, it should not necessarily be perceived consciously. So even without conscious or unconscious content, that can make some differences in neural patterns. And then the brain just take the differences between the states. So even in dreams, even in sleep state, without any dream, I think the brain still can have or take some differences with some content without conscious. I don't know whether it's all makes sense or not, but does it make sense?
Yeah, so I guess it would be interesting to use a different type of data, for example, heart rate variability and like respiration, and like record these data and use a very similar model on that, and try to see whether this model actually agrees with the subjective time perception of the person who was sleeping. Because I guess, like, yeah, it's the other issue is how do you, so because this model is based on saliency, how do you assess saliency for interoceptive signals, or what is that? That is unclear for me.
So first, I did not go into the detail of this paper, so maybe I wrong, but in this paper, they set some threshold, and this is this can be moderated by the attention, but I think it just be some Gaussian, so random like threshold. So I don't know whether, because whether the difference is salient or not can be or should be determined by the threshold. So I don't know how that threshold can be verified in a biological perspective, but at least in this paper, they just use some Gaussian noise, if I understand correctly. So, but yeah, the threshold, it's a bit difficult, or I don't know how the brain define the threshold. But yeah, sorry, I don't know, nothing. I thought maybe some not sure. Well,
Yeah, I'm not sure either, but it would be very interesting to see. Because yeah, I think in this case, the saliency of a visual stimulus is much more easy to understand, at least for me, to kind of like, yeah, obviously if you see this field and then suddenly there's a cow, yeah, that's a salient signal. But then how is that again with auditory signals? Again, it's more easy to understand or imagine. With interoceptive signals, for me, it's a bit like, yeah, more difficult.
Yeah, I see. Yeah, it's not related to the previous your question, but I also have another question. That is, so in this paper, the time window was in a sense fixed, and then count the significant difference within fixed time windows. But in our daily life, we do not have such kind of time window, obviously. So I don't know how we can interpret this, like counting the salience difference in the time window in daily life situations. Also, yeah, possibly one interpretation is that when the salience difference happen, can be considered as the timing of sampling of time or something. But still, I don't think this paper does not mention anything about the fixed time frame, or how can we like interpret this result in a like continuous time framework. So that's my question, and if you have anything or any idea to answer this. Do you have anything?
So you mean in this study, the time duration is but less than 1 minute, or one second to 64 seconds. So it is too short. You mean, or it's not?
No, I do not mean that. What I mean is that, so in this project, they present some videos, which obviously have some duration. Let's say they can present 5 minutes videos or 10 minutes videos and blah, blah, blah. And then they count the salient difference within the fixed time frame, right? But in our daily life, we do not have, let's say, 5 minutes time window, 10 minutes, 5 window, blah, blah, blah. It's just continuous. So for me, it's a bit difficult to interpret this, how we count. And one possible interpretation is the timing of sampling, as I said. So when the significance difference happens, it can be like a sample that some data or the time. And then after like another salient difference happen, then again, sample the time. And if we can interpret in that way, we do not care about the time frame anymore. But I'm not sure whether that time frame stuff were mentioned in this paper. So I just wanted to ask this to you guys.
I see.
So one thing I think they mentioned, if I remember correctly, is that when you have, so when people allocate attention to measuring or tracking the time, that is actually somewhat different, or it kind of modulates the time perception versus when they don't. And so in this task specifically, I think people were asked to estimate the time. And so I think in this way, this model can be considered more of a more of a model for when people are trying to estimate how much time or track the time, you know, like specifically or with actual mental capacity divide or oriented towards that. And yeah, so I think it's not necessarily they don't necessarily mean to generalize this model to all kind of time perception, but like in a more limited way, this model can be used for like identifying or kind of modeling, at least in some way, in a very preliminary way, how people try to guess or estimate time when they need to. Or at least that was my understanding, or that was one of the one of the assumptions I come up with, I think.
I see. So you're saying that we are not always conscious of time. So when we have attention to time and we are aware of time, then we can start to apply this model. Okay, then, yeah, I understand that. Yeah,
maybe I don't know,
because I don't know. When I read this paper, and as I explained, this model count the significant differences. So it will just increase as you live. And then the amount will be very huge. There can be some difference between like subjects or the human. And that does not necessarily match with the physical time they live. So for example, let's say if some person died at the age of, let's say, 80, we can physically measure the time they live. Let's say 80 times 365 days times 24 hours time, blah, blah, blah. But that is the physical measurement. And if we want to measure how long do they live in a subjective way, if we can count this, the change, salient change in neural pattern, maybe we can count how long they live subjectively that was kind of my ideal, just crazy or stupid thought about this.
Yeah, but then you actually have to kind of determine the threshold at that point. So it will be kind of, assessed with the perspective of I don't know, 80 years or something.
Yeah, so it is so interesting. And I think that at least three patterns of times. One is the artificial time, right? The 24 hours or 1 minute is 60 seconds. It's artificial, and we decide the time and definition the time. And the secondly, biological time for heartbeat or revolution of the cells or something. And thirdly is the subjective time. And you said that how we feel or subjectively time. So I think the biological time is like the introspective or internal information. So I think there is a relationship between the biological time and the subjective time. And I don't know the artificial time, right? The 24 hours or something minutes, how relate or not relate, I think.
Yeah, that's an interesting point, because I did not think about the circadian rhythms, so the biological time. And I'm sure that there will be some relation between like subjective time and also biological time. But I'm sure that they are different, not exactly the same. So yeah, if we are talking about time, maybe we need to be careful about what we are referring to, whether the subjective time or biological time or the artificial, like a physical time. Yeah, that's an interesting point.
But in relation to that, I think Ryoshi makes a very good point that, for example, heart rate, it's an inherently, like, there is a pacemaker there. So if we talk about, so because I guess in the paper, they argue against the existence of a pacemaker or the need for a pacemaker, or structure in the brain. But then if you integrate interoceptive signals which contain the heart rate, then you kind of inherently have already some kind of pacemaker-like feature. So yeah, so yeah, I think it would be like, I think this model would very much benefit from more discussion on the interoceptive signals and how they fit into this model.
Yeah, so I agree with you, Aniko. I do not, or I haven't read the paper yet. I mean, I saw one paper on Twitter and published in, I think, the Cell Report or something, and where the authors measured some heart rate while seeing some movies or something. The heart rate correlated, or not correlate, matched, I mean, in more strong way between the subject. So from heart rate, we can estimate what they experience or something. So, but sorry, this is just a quick glance of the paper. So I did not fully read the paper, so I might be wrong. But yeah, the heart rate is very important, and itself has kind of work as a pacemaker. So I agree that this model already, or if we extend this model to other modality, interception or the audition or just everything, then that can include some pacemaker informations. But I think what the author tried to say is that, well, without pacemaker, we can still infer the time perception, at least in this vision time frame case. So that's the point, I think. So that if we include some pacemaker information, then we can estimate the time perception more precisely. So in a sense, the key is not the pacemaker, I think, rather the count of salient changes. That's what this paper claims.
Yeah, and but this kind of relates to one of my questions, which is, I think the authors don't really address it, or I don't remember reading about this. What can be the neural structure, the neural basis of such process? Because I think in their model they have the neural network, and then they extract this pattern, the activity changes, and then they add the threshold, and then finally use a support vector machine to kind of to guess which of these signals, or kind of evaluate how these signals relate to the length of the video. And so technically that whole thing would be within the brain. And yeah, I wonder actually, what can be the neural basis, or what would be the neural structures underlying this? I mean, of course, saliency and attention, we have several different regions and a whole set of different networks. But then, this kind of estimating its temporal relationship, I don't know. Have you guys heard about any ideas or any hypothesis what can be a neural basis of this, or similar kind of processes?
So I think that the authors briefly mentions that insular can count the salience difference or change. But just briefly, and I think only one sentence. So I feel the author do not fully give the biological correspondence of these models, and that kind of related to the another aspect or the point made in the discussion part, which is the relation between this model and the predictive coding models. And if we can connect or put this model into the predictive coding framework, then from there, maybe we can infer some biological correspondence from the predictive coding literature. I think in that area, there are some candidate brain regions that can be directly or translated into this model, I think. But yeah, not sure, because it just discussion part. So
yes, I agree with you. Then yeah, in discussion part, the insurer, and I think the posterior insurer, or sorry, insurer is important for time perception and integrate the external information and internal expressed information. So, and I think in this study, the authors made the model for visual perception time, right? So this model is for by visual attention, surveillance, and visual information. And in this study, also the participants conducted the experiment like the same situation, visual information only. So the model fit is the time perception for visual only. So the next, I think that we can use the other information, like auditory information or intercepted information, and we will make the time perception model for the including the other perception modalities, right? I think. And also, Insura is important for the time perception. We can conclude.
Yeah, this is just I think the very first study of this kind. So I think from here, they are trying to, see whether there are some biological correspondence in the brain. So we can, I don't know, simply record the fMRI activity or something, and then we can see the difference between, or difference in fMRI activity patterns, and we can test whether that match with the time perception. And Aniko, you mentioned that there is one paper published in, or still reviewed in some journal, a preprint in the bioarchive. And I do not read the paper, of course, but I guess that they study some neural activity or investigate the neural mechanism with this model or framework.
Yeah. So I think the authors, or at least some of the authors, have a more recent work, which is still in a preprint stage. So it's definitely something to look up now. Where did they go after this? But can I come back to another issue or another question I have? So again, a few minutes ago I brought up sleep. There's another interesting state which is sensory deprivation. So I don't know if you guys have been or have tried sensory deprivation chambers. I have not, but what I have heard is that people actually tend to be either like they have very drastically different experiences of it. So some people really enjoy it, and like their time perception specifically just stops, and it's like they feel like they spent 5 minutes there and it was actually an hour. And then for other people it gets actually very, very stressful, and again, after a few minutes they feel like they have been there for hours and it was only a few minutes. And so in this way I am actually a bit skeptical or hesitant to agree that it may be a very straightforwardly applied system, but they propose to human time perception, because I would assume if time perception basically just the integration of sensory signals from external and internal sensory signals, and then with the thresholding you kind of guess these salient informations, and then you time them kind of, and then you end up with a different level of so a time estimate. But then why do people react so differently to sensory deprivation? Technically you wouldn't have, like, all people then most likely don't have any external or very few external signals coming in, so they have their internal signals. Yeah, but then why is it so different for people? For different people, do you have any ideas?
So, you mean that the sensory deprived, sorry, it's a subjectively time, right? So I think after of your comments, like the changing between the default mode network and the executive or those are attention network something. So if in the party it is so it is enjoy, I think the executive mode or external mode is always occurred, but it is not in fun. I think that like the mind wandering or something for think for me or think about me. So I think this is like the default mode network state. And the saliency is like the change signal for the insurer according to our leading papers, like the anti-insurer is a something gate the network between default mode and DOSA network. I think that, yeah, I think.
So my just brief guess is that maybe some memory plays some important role here. That can be somehow affect the, I don't know, threshold proposed in this model, and then that changes what counts as a salient or not. And depending on the, this threshold, some people feel longer and some people shorter, but I don't know.
Yeah, I guess like it would be very interesting to to record a lot of different bodily signals from people in sensory deprivation and look at what their time estimate is. But yeah, again, I think that's also another kind of interesting state. And something else, again, the flow state. So are you guys familiar with the flow state? So it's basically, so it described as this very happy and calm state when people can really focus on something they enjoy to do, but it's also like it's the right amount of difficulty, and then they actually lose the sense of time commonly. And again here, so like I think the predictive coding or active inference understanding of the flow state is that it happens because then like these predictions and like the bottom-up signals are exactly in the right, I don't know, balance, and it's just the right amount of kind of challenge or like people are very good at predicting and so they really enjoy this state. But that kind of implies that there's this right amount of saliency. And why would then time perception kind of disappear? Yeah, I don't know.
So I'm not sure whether I understand your question correctly, but like in this paper, at least when they say attention, it means attention to time. So if someone in flow states, then the attention to time will be just disappear, or the attention will be used for time. If we consider or interpret that way, then I think this model can still explain what to or suggest or flag, I think.
Yeah, I see. Yeah. So I think again, I think this would need some clarification or more studies whether like this attentional threshold adjustment, like what exactly is it? Is it specifically time related, or is it more about saliency related? Because that kind of leads to different conclusions, or to different paths.
Yeah, Ryoichi, do you have any questions? Because I don't think you asked any question.
So yeah, but I'm wondering how to relate the usage of predictive coding or so feedback or recurrent loop and how to integrate the multimodal time scale. So just I'm wondering and I'm thinking.
I see.
So,
yeah.
And,
as you mentioned,
yeah.
Go ahead.
Oh no. I'm other question of this paper. I'd like to know the relationship between the sleep and the time perception and the information. So I think sleep awareness. So my interest when I have a dream, so long story, but when after I awake and the time is not past, so I have the big story in the brain, but the artificial time I pass the 30 minutes or only an hour passed. So dream, I think the real experience time and it's different from the dream the experience time in the dream. So what do you think?
Yeah, so first, before going to the third one, I am also interested in the feedback or recurrent processes. Because in this paper, as Ryoichi mentioned, the authors only focuses on the feed-forward. And they says that even in the feed-forward network, we can estimate, or using information from the feed-forward network, we can estimate the time perceptions. But it does not mean that this is the mechanism of like our subjective time perception. What they say is that just we can estimate the time perception. So that's the very big differences. So I'm curious how the recurrent or feed forward is necessary for the subjective time perception or the mechanism of the subjective time perceptions. On the another like the third one, I first need to introspect my dream experiences, but no, I just I don't know, just
Yeah, so I think there's again these two different questions, whether whether time perception exists in dreams and how accurate is it. You know, you can, like, for example, if you have a very long and complicated dream, you may be assuming that it was long because there has been several interesting, or like there was this long narrative, and then you can think of several salient points, and then you kind of make your inferences of that. But then I guess it's also when you wake up, you may have a different, like a different understanding of how much time has been has spent, or how much time have you spent. And yeah, so I think that kind of relates to, and so I remember that there are at least a few studies on this time perception in dreams. But I think they specifically relate to how, when you're awake, whether you can tell how long you have been dreaming, and not the subjective experience of time within the dream. Yeah, maybe there are also studies on that. But yeah, it's definitely an interesting question.
Thank you. Yeah, so it is so interesting, and I have another question. The relationship, right? If not information, how about the speed of the information pathway or something? So, or complex of the network, it's related to the time perception, or some. I'm wondering. So the rapid information conveyed. Sorry. For example, in the myelin in the neuron, myelin. You know myelin in the baby, the myelin is less, so it is so our feels the more for baby or young children, it need more time to perceive external world, and one examination of the factor is the myelin in the neuron. So the speed of the information or complexity is related to time perception, I think. But what do you think?
Yeah, I think so. First, as we add more layers, the information or the activation should be propagated slowly than the less layered neural systems. In that sense, when we take the difference between like 2 time steps, that can be somehow affected. But yeah, in a sense, you raise a very interesting point, because here the neural system they propose has their own like fixed time step. So the neural system itself has, I don't know, have certain time step, a fixed time step. But as Ryoichi says, that like the brain is complex, and maybe the different area has, or different neuron has different time step, or depending on the length of axons, maybe the speed of the processing can be different. Not sure whether how that will affect, or how much that will affect the result in this model. But yeah, that's very, I feel, interesting.
Yeah, and on that note, I think so. This model is definitely based on human which or like they are trying to focus on humans. But again, about this, like how quickly information travels within the brain, it's an interesting question to think about whether, for example, fruit flies or very small animals have different time perception as opposed to larger animals, like or humans, for instance. Yeah, so I think in that way, I think this model, I don't think it's necessarily like strictly only fits to humans. Yeah, I don't know. But yeah, I think it's always, it has been an interesting question whether time like goes as fast for all animals or different animals, like similarly to humans.
Yeah, I've never thought that before. I mean, the differences of time perception between animals. Obviously some species have less like lifespan. Let's say some species, I don't know, or I do not have any like a good example, but let's say ant, very small insect. Let's assume that they can just live for 1 year. This is just assumption, and I know that this is not correct, but if we can measure their subjective time perceptions and compare it with human time perception, the subjective one, maybe the objective time length, time duration of the lifespan should be, or obviously the human should have lived longer than ants. But in terms of the subjective perception, maybe we live exactly the same, the time duration, length of life. So yeah, I've never thought about it before. So that's really interesting point, I feel. Yeah. Do you have any other questions? I think we've already discussed about 1 hour plus 10, 20 minutes. Not sure exactly, but if you want to say something.
Yeah, I guess, yeah. Just so like I think it was a very interesting paper, but it yeah, I think it's, and yeah, time perception is such an interesting aspect of subjective experience. But I definitely got more questions now than before, so maybe that's a mark of a good paper.
Ruchi, do you want to say anything?
Yeah, good paper. And good discussion. Yeah.
Yeah, I myself feel like while reading this paper, it was really fun, actually. And maybe if I measure the time perception while reading this paper, can be shorter because I did not pay attention to time. Anyway, so maybe we can finish our discussion here. See you next week.